Thank you. Thank you, Chairman. Here is an overview of this presentation. First, I'm going to explain about these contents. I'll then discuss the results from this study and end with my conclusions and future works. Here is the number of cattle in production in 2017. In Japan, overall, there are 1,323,000 daily and 2,499,000 beef cattle. Collectively, about 63% of all daily cattle were in Hokkaido. BVDV infections was designed as a notifiable disease in 1998. Based on animal disease control measures in Japan, since 1999, systematic vaccinations have implemented in areas with BVDV infections, and persistent infection in cattle has been eliminated voluntarily. This group shows the number of BVDV infections and diagnoses. The red bar represented the number of cattle with BVDV infection in Hokkaido, while the green portion is the rest of Japan. The blue line is the number of diagnoses at Hokkaido livestock hygiene service centers. This has been continued increased in the incidence of BVDV infection. At Hokkaido livestock hygiene service centers, we have performed 3,000 to 4,000 tests a year between 2005 and 2010. In 2011, the tests were implemented for prevalent purposes in one region district of Hokkaido. Since then, the number of tests has increased to 8,000 to 10,000 a year. While the increased number of tests, the incidence has also increased. Next, I'd like to discuss the result of my study. In order to control BVDV infection more effectively, we studied previous cases persistent infections by collecting epidemiological information of 765 persistently infected cattle that were identified in Hokkaido between January 2011 and December 2015. We examined age and breed, the clinical symptoms, age and vaccination history of dams, and the suspected location of infections. If the dams has stayed in the same farm between 30 and 150 days at gestation, we determined that this was the suspected location where the infection occurred. Genotyping was performed by phylogenetics tree analysis. Specifically, BVDs were isolated from 160 of 765 persistently infected cattle, and the sequence of 5' untranslated region was determined to classify the isolated into genetic subtypes. This analysis was performed at the Laboratory of Microbiology, Faculty of Veterinary Medicine in Hokkaido University, and I would like to thank those who were involved. Here is breakdown of 765 persistently infected cattle. Dairy and beef were almost the same number, and the majority were calves under the age of 4 months. (647) showed no clinical signs of infection. In cattle that showed clinical signs, stunted growth was the most common observation, followed by diarrhea and respiratory symptoms as shown here. This graph shows the vaccination history of the dams. The history was unknown in 543 dams, and this was the most common finding. There were 44 dams that had not been vaccinated, and 107 48 dams that had been vaccinated. The majority were vaccinated twice with bivalent inactivated vaccines. In this survey, we did not have data to mention about the effect of vaccine. In terms of the age of dams by month, 327 dams, 42.7% were 24 months or younger. We are able to determine the suspected location of infection in 533 of 765 cattle. We identified 227 farms, and 8 of them were suspected to have had infection at least 5 cattle annually. 6 of these farms, it was read, were public ranches and facilities for pregnant cows, and the remaining 2 farms were large farms with at least 200 adult cattle. For example, 36 persistent infected cattle that were suspected to have been infected on Farm 1 has spread across 18 farms, potentially causing widespread persistent infections. A total 100 isolated have genotype 1 and remaining 60 had genotype 2. Further classification revealed that 23 isolated were subtype 1A, 66 were subtype 1B, 11 were subtype 1C, and 6 were subtype 2A. There was no significant difference in the proportion of subgenotypes across the year, although type 2 was more common in 1 year. Lastly, I would like to end with our conclusion and plans for future work. The majority, 62.4%, were age 4 months or younger, and 84.6% had no clinical signs of infection. This suggested that in Hokkaido, BVD infection is detected in young cattle before mucosal disease develops. This is likely a result of proactive measures taken in Hokkaido to prevent the infection. Our findings on the genotype of BVDs were in accordance with studies published previously and indicated that genotype 1 and 2 were both prevalent. While we were unable to determine the efficacy of vaccines from these data, previous studies demonstrated that they were effective to a certain degree. Collectively, these findings suggested that vaccination with BVDV bivalent vaccines based on the prevalence of epidemic is critical. Since information with genotype 1B was also common, we may need to take this into consideration for vaccination in the future. 42.7% of the dams were aged 24 months or younger, suggesting that the dams that are pregnant for the first time may be at higher risk of infections. Thus, a vaccination program should be implemented during the rearing period before mating to ensure that the dams have sufficient amount of antibody. A large number of dams, especially those that are pregnant for the first time, are raised at public farms or those that provide temporary housing for dams. The data suggested that infection of large number of dams occurs simultaneously in these places where pregnant cows from multiple farms are raised, resulting in further spread of the virus. Considering the current prevention strategies implemented in Hokkaido, it may be most effective to eliminate persistently infected cattle from a herd before they are transferred to these farms where pregnant cows were raised. In Hokkaido, implementation of strategies at one farm and within one region has been effective in reducing BVDV infections. However, there was still a need for the prefectures to come together with common goal to address the issue of BVDV infection. Thus, 5 fundamental plans of action the prevention of BVDV infection were established in 2016. First, cattle producers, veterinarians, and associated institutions should collaborate and share information to ensure that the cattle producers fully understand the preventive measures that need to be implemented. Second, if a cow shows signs suggestive of BVDV infection, it should be examined rapidly. Such examinations, including surveillance measures, should be implemented effectivities across the entire region. Third, persistently infected cattle should be identified and eliminated. Fourth, cattle should be vaccinated before mating to achieve the best effect. Last, hygiene management strategies for rearing should be in place to prevent viral spread. In order to ensure that each region is working together to implement these 5 fundamental plans of action, we are providing leaflets to raise awareness of BVDV infection among the caretakers and any others who are involved in this process. In addition to the fundamental plan of action in Hokkaido, guidelines for the prevention of BVDV epidemics was established in Japan after our survey period in 2016. Measures to control BVDV infections have been implemented across Japan with the goal to eliminate the infection from our country. We will continue our investigations to help prevent BVDV infections. I'd like to thank those people. Thank you for your attention.